We have previously seen examples of conducting a two-way ANOVA using the null hypothesis that all group means are equal. But we've also seen examples where we could use categorical variables having been converted into indicator variables and using a regression model. We've done that in one-way ANOVA, we've done that for two sample t-tests, and there's no reason why we can't do that for two-way ANOVA. So that's what this video is going to show, that really converting a two-way ANOVA model into a regression model yields the same results. We just have to be mindful about the interpretation of our effects. So our model in the population would be mu sub y, the true mean, in this case attractiveness, is alpha plus something. So we have to create our indicator variables. So we're going to do that in this table here. Remember, we have two categorical variables, one for self-reported gender of the participants, and then one for the amount of beer consumed, 0, 2, or 4 pints. And both males and females had opportunities to drink either 0, 2, or 4 pints. So we have 6 possible combinations of the two categorical variables. We have to convert each of the gender and the beer variables into indicator variables. So I'm going to have 3 possible indicator variables. 2, x1 and x2 for beer. So this x1 and x2 are going to indicate the amount of beer consumed, and x3 is going to be the indicator for gender. Now remember, if we have 3 levels of a categorical variable, say 0, 2, and 4 pints, we only need 2 indicator variables. That third indicator variable would be redundant, because if a person has not had 2 pints, if a person has not had 0 pints and has not had 2 pints, then they must have had 4 pints, and we don't need that last indicator for 4 pints. That 4 pints in this case would be the reference group. Similarly, if we only have 2 levels of a categorical variable, male or female, if a person is not female, in this case, then they must be male. And so we do not need a second indicator because one of those 2 groups, in this case male, must be the reference group. So we're going to start off by coming up with indicator variables for the beer categorical variable. We're going to say that 0 pints is going to be our reference group, or our default group, as the sort of language we've used before. Because it's really sort of interesting to see, relative to having no beer at all, 0 pints of beer, what is the change in the response for someone who has had 2 pints and someone who has had 4 pints. So 0 pints, having no beer at all, seems to seem like a reasonable change. 0 seems to be the default. The default is you wake up in the morning and I assume you've had nothing to drink. So our indicator variable x1 is going to be for 2 pints, and our indicator variable x2 is going to be for 4 pints of alcohol. So what we need to do now is that for females who have had 0 pints of beer, what is going to be the value for x1? And then what is going to be the value for x2? You're right. For someone who has had 0 pints of beer, because x1 and x2 are indicators for 2 and 4 pints respectively, both of those indicators are going to be 0. For a female who has had 2 pints of beer, what should be the value for the indicator x1 and what should be the value for indicator x2? You're right, because x1 is the indicator for 2 pints, that should be a 1. We are indicating correctly that they have had 2 pints of beer. Because x2 is the indicator for 4 pints, that indicator should be 0. For a female who has had 4 pints of beer, what should be the values for the 2 pint and 4 pint indicator x1 and x2? Again, yes, the 2 pint indicator should now be 0 and the 4 pint indicator should now be 1, because they have not had 2 pints and they have had 4 pints. Now please fill in the male 0, 2, and 4 pint indicators. I hope your work looks like mine. Just like for the females, a male who has had 0 pints has not had a 2 or a 4 pint, so their x1 and x2 should both be 0. A male who has had 2 pints has had a 2 pint, has not had 4 pints, so the 2 pint indicator should be 1 and the 4 pint indicator should be 0. And the male who has had 4 pints has not had 2 pints, so the 2 pint indicator x1 should be 0, and the 4 pint indicator x2 should be 1. Now we need to do the indicator variable x3, which is the indicator for gender. And we're going to make this an indicator for female. So this is the female indicator. This is going to be a little bit more straightforward. Females are female, and so they will get a 1. The males are not female, so they will get a 0 for the female indicator. Now what we want to do is fill in the mean of y for each of these combinations within the model. It might help to complete what we were starting for our model up here, because now we know how many variables we have. We have 2 indicator variables for the amount of beer. We have 1 indicator variable for gender. So our overall model is alpha plus beta 1 x1. So this gives me the main effect for 2 pints of alcohol, plus beta 2 x2, the main effect based on 4 pints of alcohol, plus beta 3 times x3, the effect for females, the gender effect. But then I also have to take into account the interactions. So I have to look at the interaction between beer and gender. So I'm going to have to multiply x1 by x3 and x2 by x3. Because remember, we had all those different line segments. So I want to see how the effect of 2 versus 0 pints changes for gender, and how the effect of 4 versus 0 pints changes for gender. So that's going to give me a beta 1,3 times x1 times x3. So this is that 2 versus 0 pints for gender interaction, plus beta 2,3 x2 times x3. And this is how the 4 versus 0 pints effect changes for each gender. So these are my interaction effects, and these are my main effects. And so now that we've specified our whole model, we can start getting at the mean of y for each of these different combinations of gender and beer. So the mean of y, and this is the population mean of y, so this is going to be in Greek letters, we can start filling this in. So for a female who has had 0 pints of beer, this is going to be alpha, because that's unaffected, plus, well, they have not had 2 pints of beer, so this term, beta 1x1, goes to 0. They've not had 4 pints of beer, so beta 2x2 goes to 0. They are female, so beta 3x3 stays in. So we're going to have plus beta 3 times x3, which is 1. Now, again, because working our way through the rest of this model, we know that beta 1,3 x1 x3, that's going to go to 0 because x1 is 0. That's the 2 pint indicator. And for the same reason, beta 2,3 x2 x3 goes to 0 because x2 is 0. So my mean of y, my population mean of y for females who've had 0 pints based on these indicators is just going to be alpha plus beta 3. Let's do the same thing for females who have 2 pints. We're just going to plug in these values of x1, x2, and x3 into this population model. So we start off with alpha plus, now x2 and x3 are equal to 1. So I'm going to have an alpha plus, x1 and x3 are equal to 1. So alpha plus beta 1, because x1 is equal to 1, plus beta 2 x1 is 0, plus beta 3, because x3 is equal to 0, plus beta 1, 3, because x1 and x3 are both equal to 1 now. So I've got alpha plus beta 1 plus beta 3 plus beta 1, 3. So the population mean of y for females who have had 2 pints is alpha plus beta 1 plus beta 3 plus beta 1, 3. Remember, alpha and my betas are all constants. They're population parameters. So I'm going to pause this video for a little bit, and I'm going to fill in the rest of this mean of y table and ask you to do the same thing and see if what your results see if your results come in are the same as mine. So pause this video, I'll fill this in, and when you start this up, see if you get the same results that I do. Alright, so I hope that you paused the video and didn't just wait for the answers. But even if you did, here's what we get. So just going through the way we did with the first two groups, females with 0 pints, 2 pints, and so on, I just plugged in these values. So x1 for females with 4 pints is 0, but x2 for females with 4 pints is 1. So I just take x2 equals 1, x3 equals 1, and I plug that into this model up here. And that means that now the population mean for females who drink 4 pints of beer is alpha plus beta 2 plus beta 3 plus beta 2,3, that interaction effect, because x2 and x3 are both 1. For males, it's a lot easier, because for males, we don't have x3 in the equation. So males are not females, so x3 is going to be 0, so we are never going to have an interaction effect. So males, we're going to be dealing with just the baseline population means. So males with 0 pints, that's just going to be alpha. Males with 2 pints is going to be alpha plus beta 1. We'll plug in x1 and we'll get a beta 1 back. Males with 4 pints is alpha plus beta 2. We plug in a x2 and we get a beta 2 back. Alright, so if we were to interpret this model, we would see that alpha is the population mean of perceived attractiveness when all of the x's are equal to 0. Well, the only time all of the x's are equal to 0 is for males who drink 0 pints. Well, and that's consistent with what we had here. Alpha is the population mean response for males who drink 0 pints. If we look up here, we can see beta 1 is the true average change in the perceived attractiveness for people who have 2 pints of beer versus those who have no pints of beer. And that's what we're seeing here. So males have 2 pints alpha plus beta 1, that's the average change for those who have 2 pints of beer versus none. And we have a beta 1 up here for females with 2 pints of beer versus no pints of beer, so that's consistent too. So we're interpreting our slope effects here the same way we would do it for multiple regression, but it's a little bit easier to think about it as these, how they contribute to our means. Now, to get to our estimated means, it's easier to actually look at our parameter estimates table. When we look at the parameter estimates table, we have a bunch of interaction terms. So here I have my intercept, so this is A. Beer, pints under 2, this is B1, or really this is my X1, and this is my B1 term here. This is X2, my indicator for those who have had 4 pints of beer, so I get B2. Gender under female, this is my X3 variable, so I have B3 here, and then I have B1, 3, and B2, 3, my 2 interactions. But I can take all of these terms, I can take all of these estimates and get sample estimates in my equation above. So A, this is my estimate, my intercept is my estimate for alpha. So my estimate, where did I have alpha up here? For males who had 0 pints. So that means my estimated mean of y is going to be A, and that is 66.875. So for males who drank 0 pints of alcohol, they talked to people with a perceived attractiveness of about 66.875 points on this 0 to 100 scale. If we want to figure out, and we'll start with the males because that's a little bit easier, if we wanted to figure out the perceived attractiveness for males who drank only 2 pints, remember that's going to give me then A plus B1, because in the population that would be alpha plus beta 1. We're just going to take A, 66.875, plus this very small number, 9.77 times 10 to the minus 15th. So this is going to be 66.875 plus basically 0. So that's going to be 66.875. So does our model estimate a big difference between males who drink 0 pints and males who drink 2 pints? No, basically none at all. So on average, males who drink 0 and 2 pints of alcohol are talking to people with basically the same level of attractiveness. Now, for males who drink 4 pints, in the population, there should be a change on average of beta 2. In our sample, there is going to be a change between 0 and 2 pints of B2. So we're going to have to look at A and B2. A, as we know, is 66.875. B2 is negative 31.25. So this is going to be 66.875 minus 31.25. And that gives me an estimated sample mean attractiveness of 31.625. On average, in this sample, males who drank 4 pints talk to people with a perceived attractiveness of 31.625. That is, males who drank 4 pints talk to people with a perceived attractiveness 31.25 points lower than those who drank only 0 pints. That is, who drank no beer. Using this same method, I'm going to ask you to pause this video and find the estimated sample means for the female groups. Now this is going to be a little trickier because you're going to have to add in the interaction term as well. So I'm asking you to find the sample mean attractiveness for the females who drank 0 pints, the estimated mean attractiveness of the partners for females who drank 2 pints, and the estimated mean attractiveness of the partners for females who drank 4 pints. So 3 sample means. So we have the population means, what they would be. So I'm asking you to find the estimates of those population means based on the output lower down in the notes. Alright, so females who drank 0 pints of beer, they started off with alpha plus beta 3. In our sample, A is 66.875 and B3 is negative 6.25. So in our sample, we estimate a mean perceived attractiveness for females who drank 0 pints of beer. They talk to people with an attractiveness of 60.25 on average. In our sample, we estimate the mean attractiveness for females who drank 2 pints of beer to be A plus B1 plus B3 plus B13. So we have that interaction term now. So that's 66.875 plus 0 minus 6.25. So there's that penalty for being female versus male, plus B13. So that's the increase or the change for the change in the effect of the 2 pint alcohol, or the change in the effect for being female versus male for having 2 pints of beer. And so altogether that gives us a sample mean of 62.5. So relative to males who drank 2 pints of alcohol, it's a little bit lower. For females who drink 4 pints of alcohol, we have A plus B2 plus B3 plus B23. So we can see that we have to subtract off this negative 31.25, the effect of 4 pints, but we're adding in together, or we're adding back in a whole big back amount, a whole amount back, which is the interaction effect of 28.125. So the effect of alcohol is not the same, the effect of 4 pints of alcohol versus 0 pints of alcohol is not the same for females as it is for males. So females are not talking to people as much less attractive when they drink 4 pints of alcohol versus 0 as males. And that's why this sample mean, 54.5, is so much higher than the sample mean of 31.625 for females than for males, because we have this non-zero interaction effect. If this interaction effect of 28.125 were around 0, then these two means would be much more similar. We would have seen the same drop of negative 31 for the change from 0 to 4 pints of alcohol for females and for males. But because this interaction of effect of 28.125, that's what's pulling the females back up to not as big a drop. So let's think about this. So we have our sample means of 60.25, 62.5, 54.5, and so on. I'm going to scroll back up, and I know that scrolling is not ideal for these sorts of videos, but that's where these plots that we looked at last time come from. When we look at, for example, the sample means, this change in the mean response, we have just estimated these 6 means. So the mean for male at 0, 2, and 4 pints, and the means for females at 0, 2, and 4 pints. And by looking at the relative effects, we can see what is going on. So we used male as the baseline. So we use this first plot as the baseline, and we said relative to this point here, how different are females? Relative to this point here, how different are females? And then relative to this point, how different are females? What we also did was we said relative to this group, the 0 pint group, how big is this change? And how big is that change? So we had 2 reference groups. We had the reference group of male, and we compared the females relative to males. And we had the reference group of 0 pints, and we said how big is that change? And by looking at that, and I'm going to erase some of these lines because I think they get a little confusing when I'm talking. And we said, well, relative to that, can we see how big these changes are? Are these changes close to 0? And if they're all close to 0, then we don't really have evidence of an effect. Or do they change? Are they very far away from 0? And if they are far away from 0, then we do have evidence for these different effects. And so, for example, we saw that B13, the interaction between, B23, the interaction effect between comparing the 0 group to group 4, this change for males was not the same as this change for females. Comparing the average for females for group 0 to group 4, there's hardly a difference at all, but the change from 0 to 4 for males was huge. The difference in that change is 28 points. That's what that B12 is. So B12 is 28. So the difference in those differences is about 28 points. When we saw B2 is negative 31, that is saying that when we average together these 2 groups together, and we average these 2 groups together, on average the difference between the average of these points and the average of these points, that difference in the averages is negative 31. So we're getting the same information that we saw before, so that's that negative 31. This B2 is saying how different is this mean from that mean. Okay, so it's using 0 as a reference group and saying how big is the change. Right? So we're getting the same information that we had when we looked at our profile plots before. We're getting the same information that we had when we looked at our effects test, but it's breaking it down into the individual pieces.